All right, so I was looking for some videos over this and I couldn't really find anything. So I wanted to show you for some of the questions where you're simplifying different types of radicals, you're going to need to kind of, it's not always going to be like a perfect cube or a perfect square. Like you might have to either do one of either one of these methods. And they're really, I'm calling them two different methods, but they're really kind of the same idea. The method two is just kind of a little bit more of a sophisticated approach of number one in a way. Method one is just a factor tree. So if you're trying to find the cube root of 192, and I pulled, this was an example from Delta Math in that third section. One way to do this is just because it's not a perfect cube. Like it's not like the answer is just 10 or 12 or 13, like a lot of the questions you're going to see. But you can just do a factor tree. The only thing that's different from a cube root versus a square root, if you know how to do square roots, is when you break it all the way down, we're going to be looking for groups of three. Whatever your index number is what you'll be looking for groups of that size. So if this was a fourth root, I would be circling groups of four at the end. Or if it was a fifth root, I'd be circling groups of five. So it's no different in that sense. So you could kind of apply this to all the different types of roots. So two numbers that multiply to 192, I could just do half of it. So 2 and, what would that be, 96? That would be 2 and 48. 2 and 24, and you could do other numbers. I'm just cutting it in half because these are all even. 2 and 6, 2 and 3. And if you want, you could, but write it out, or just kind of look at what you got. But you're just looking at your end results or your prime numbers. So, and you're looking for groups of three because it's a cube root. So we got a group of 3 2s, another group of 3 2s, and we got this 3 is left over by himself. So each one of these groups, you pull one of them to the outside of your radical. So you'd have 2 times 2, or 2 squared is 4. And then since you had that 3 left over, it stays underneath your cube root. So this is method one, and sometimes you can be a little bit smarter about the numbers you choose. Your tree might not get like this ridiculous, but it's kind of brainless. I will admit this method one, but I think it's intuitive. And honestly, this is the method I will use a lot myself. Because method two, it requires some knowledge, or you really got to kind of practice some facts to get good at method two. Method two, and this is how the Delta Math video is going to show you. It's basically to pull out perfect cubes, or if it's a fourth root, you're going to pull out perfect perfect, what would it be, quartics, or perfect quintics if it's a fifth root. So remember, your perfect cubes, like 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubes 125, and hopefully we don't have to deal with anything bigger. So this is really the same idea, but basically what you want to do in this method, and what they're going to show you in Delta Math, is there any perfect cubes that divide into this number? And I don't know how good your guys' mental math is, but 64 would go into 192, like 64 times 3 actually. You could also pull out an 8, but it's to your advantage to pull out the biggest perfect cube if possible. So you could rewrite this as the cube root of 64 times the cube root of 3. I don't know if you know this about radicals, but it's kind of like when we did the imaginary numbers, but you can multiply radicals to like get what's underneath. So if you multiply this, you'd be back to where you started. But the cube root of 64 is 8. And then the cube root of 3 is just the cube root of 3. Oh, the cube root of 64, sorry. The cube root of 64 is 4, not the cube root of 8. You see, you get the same answers. I mean, technically, you really are kind of just doing a factor tree for method two, but you're trying to you're taking the time to be a little bit more strategic about what you're pulling out, if that makes sense. So if you watch the Delta Math videos, that's how they're going to kind of show you how to do it. And method two, at least for me, and maybe I'm just like a pleb with my mathematical ability, but I feel like method two, it looks really great when you see it, but sometimes it's kind of hard on your own, especially if you're dealing with really big numbers or something. It's like, I don't know if a perfect cube goes into it or not. So a lot of times I'll just do method one. But I don't know, maybe I'm just like, maybe that's bad advice. But that's kind of how I've always looked at it. So I hope this kind of helps a little bit. Like I really don't care what method you use in terms of these. I mean, they really aren't different methods. I mean, they really are the same thing. Just that there is a little bit difference of a mindset when you approach a method. One is kind of like I feel like you're just not thinking and you're going for it. Method two, you're being a little bit more, you're thinking about things, which is good. I would honestly, if you can, I would maybe push you to try number two. And if you can, it's definitely faster and it's definitely more sophisticated, but to each their own.